Hi, I'm Mercedes Hanley. I am a student at the University of Buffalo. I am taking Professor Maduri's EE478 VHDL design class, and my topic for this presentation is optimal state assignment of finite state machine. In this presentation, I will be talking about 4 ways to optimize the state assignment. First is the propagation delay. Second is the area of the integrated circuit. Third is the PLA or programmable logic array. Fourth is the power consumption. In electronics, digital circuits, and digital electronics, the propagation delay, or known as the gate delay, is the length of time which starts when the input to a logic gate becomes stable and valid to change to the time that the output of the logic gate is stable and valid to change. Second is the area of integrated circuits, and as the technology for the circuits become more advanced, the smaller the area is going to become. In PLAs, switching activity can be minimized by the way the programmable logic array is implemented. Finite state machines use PLAs, which are programmable logic devices used to implement combinational logic circuits. There are different ways to optimize the way that the PLA is coded. The different ways that we will be discussing in this presentation are column-based algorithms and sequential algorithms. For the power dissipation, there are different parameters that we can change that will affect the amount of power that the circuit draws. Complementary metal oxide semiconductor, or CMOS, logic was invented by an electrical engineer named Dr. Frank Morin Wanless, and now CMOS technology is the most popular technology for the construction of very large-scale integration circuits, VLSI. The reason being is that the CMOS uses much less overall power compared to the NMOS and the PMOS design alone. The CMOS is a complement of both NMOS and PMOS. It draws less overall power because it is designed so that one of the two transistors making the CMOS is always off. This means the integrated circuit is drawing a significant amount of power for a moment while it is switching between its states, on and off states. The CMOS design can be seen in the diagram. From this, a finite state machine can be demonstrated by using the discrete Markov chain. Markov chains were developed by a Russian mathematician in the late 1800s. A discrete time Markov chain is a process in which it transitions from one state to another with the probability distribution of the next state depending on the current state. This means it is not depending on the past sequence of events that it has gone through. A Markov chain is very beneficial because it works well with very large-scale integrated circuits. It keeps the switching activity in the circuit to a minimum while reducing the amount of code. The figure below gives a visual concept of how the probability of the Markov chain works. In digital design, two of the most common finite state machines are the Mealy machine and the Moore machine. The Moore machine's output are completely dependent upon its current state only. However, the Mealy machine's outputs depend not only on the current state, but also on its inputs. The difference between the Mealy machine and the Moore machine are given in the block diagrams. Programmable logic devices are tools used to implement combinational logic. Finite state machines use programmable logic arrays, which are programmable logic devices used to implement combinational logic circuits. PLAs perform similar basic tasks as a read-only memory, which is a ROM. If a PLA has, for example, n inputs and m outputs, it can have m amount of functions with n variables. The picture shows an example where 3 inputs, A, B, and C, has 5 product terms, A0, B0, A, C0, B, BC-NOT, and AC, and has 4 outputs on the transistor level. Seeing the amount of transistors in the PLA in the previous slide gives a good idea of what Moore's law is. Moore's law, which is named after Gordon Moore, who was the co-founder of the company Intel, is an observation made by Gordon Moore about transistors. The thought, which proved to be true, was that every year the number of components in an integrated circuit would double. He said that for another decade at least, the rate of growth would continue for another decade. A few years later, in 1975, he reconsidered his projection and changed it to doubling every 2 years. Moore's law is simply a projection, really an observation made by Moore, and is not a natural or physical law. However, Moore's law has held true for several decades. It has been used as a target for the semiconductor industry when setting goals for research and development. Column-based algorithm is based on the concept of the indistinguishability classes. Two states having the same partial code are said to belong to the same indistinguishability class. Annealing algorithm is a non-deterministic algorithm, which means that even for the same input, it may have a different output. There is no consistency with the algorithm. It uses, described below, the function gamma, which describes the switching activity that occurs, which is connected with the state code, which is described as CI. The problem being solved is split into 2 problems, the master problem and the subproblem. The master problem is the original problem with only a subset of variables being considered. The subproblem is a new problem created to identify the new variable. The objective function of the subproblem is the reduced cost of the new variable with respect to the current dual variables and the constraints required that the variable obey the naturally occurring constraints. As discussed earlier, the only time a CMOS-based digital circuit dissipates power is when there is a transition at the output. This is based off of the assumptions. First, that the power is dissipated through capacitance at the output. Second, that the current flows from the power supply voltage to the capacitor or from the capacitor to the ground. Thirdly, that the output voltage will change from DDD to 0 volts or the opposite, 0 volts to VDD. From this, the power dissipation can be defined as the following equation. In the equation above, VDD is a power supply voltage, T cycle is the time the switching activity is calculated, CA is the output capacitance relative to the element A, and NA is the switching activity of the element A. Both the capacitance CA and the power supply voltage VDD are dependent upon the manufacturing process of the transistor. They can be considered as constants when analyzing the equation. The switching activity, NA, is a source of concern when trying to optimize the power consumption. The switching activity of the element is defined as the number of switches per unit time, which is typically 1 clock cycle. In conclusion of this presentation, there are different ways to optimize state assignment for finite state machines. It can be done both using hardware and software. When using hardware, it is up to the design of the chip, and when using software, there are different ways to program the integrated circuit.